Three major AI systems just launched at the same time, and together they signal something much bigger than feature upgrades. OpenAI dropped GPT-5.3 Codex Spark running on Cerebrus Systems wafer-scale hardware for real-time coding. Google upgraded Gemini 3 DeepThink with elite reasoning and Sketch 2 3D generation. And MiniMax released M2.5, an agent model cheap enough to run continuously. Fast coding, deep reasoning, always-on AI agents. So here's the real question. Are we watching the moment software development fundamentally changes? Because this isn't just model iteration. This looks like specialization. Let's break down what's actually happening. OpenAI, the speed layer codex, has been drifting into two very different use cases. One, long autonomous missions, planning multi-file edits, running tools, debugging across large repositories. Two, tight real-time collaboration. You're in the editor. You change a function. You tweak a UI component. You want instant feedback. Codex Spark is built for that second mode. It's described as a smaller GPT-5.3 Codex variant optimized for fast inference. Translation? Lower latency. Near instant response. Why does that matter? Because developer flow is fragile. If responses lag, you break momentum. If responses are instant, you iterate faster. Spark runs on Cerebrus WSE3 wafer-scale engine, a single massive silicon chip with trillions of transistors instead of traditional GPU clusters. This is not general compute. This is latency-first hardware. OpenAI is essentially saying intelligence alone is not enough. Interaction speed is part of intelligence. And they didn't just speed up the model. They optimized the entire stack. Faster session initialization reduced time to first token persistent WebSocket connections, pipeline refactoring to reduce network overhead. Because real-time AI is not just about the brain, it's about the nervous system. Now here's the trade-off. Spark scores lower than full GPT 5.3 Codex on deeper benchmarks like Terminal Bench 2.0. That's intentional. Spark sacrifices some reasoning depth to gain responsiveness. And here's the strategic insight. Not every coding task is a marathon. Most are sprints, refactor, rename, patch, adjust, repeat. In that loop, speed wins. So OpenAI is carving out a new compute tier, GPS for scale. Specialized hardware for instant collaboration. But speed alone doesn't solve the hardest problems. That's where Google enters. Google, the cognition layer Gemini 3 DeepThink is positioned differently. Not chat faster. Think deeper. Google frames this upgrade around science, engineering, and research. Domains where uncertainty is high and mistakes are expensive. Benchmarks they highlight: 48.4% on humanities last exam. 84.6% on ARC AGI to 3,455 ELO on Codeforces. Gold level performance on the International Math Olympiad 2.0-5. Those numbers target different audiences. Codeforces ELO signals competitive programming strength, algorithm design, constraint handling, optimization. Arcagi suggests generalization and abstraction beyond memorized patterns. IMO-level performance signals structured mathematical reasoning. But the deeper shift is test-time compute. DeepThink allocates more internal reasoning steps before answering. In other words, it verifies. And verification changes everything. Because the next frontier isn't just intelligence, it's reliability. If AI is used in engineering design, scientific modeling, or infrastructure decisions, confident wrong answers become unacceptable. Now add something practical. Sketch 2 3D generation. Draw a rough shape. The model interprets geometry, generates a 3D model, outputs a printable file. That's reasoning connected to physical output. It bridges abstraction and artifact. So Google is pushing a different thesis: depth over speed. Cognitive stability over conversational agility. But there's a third axis that might matter even more: cost. MiniMax. The economics layer MiniMax M2.5 isn't optimized purely for speed or depth. It's optimized for sustainability. Their claim is aggressive. Run an agent continuously for an hour at high throughput for around $1. Why is that disruptive? Because agent systems are expensive. Agents retry, search, call tools, reevaluate, loop. Cost compounds fast. If cost drops dramatically, always-on autonomous workflows become viable. M2.5 reports 80.2% on SWE bench verified 51.3% on multi-SWE 76.3% on BrowseComp. But the interesting claim is behavioral. The model plans before coding. It structures architecture first, then implements. That alone reduces rewrite cycles. They also emphasize training across 10 programming languages, exposure to over 200,000 environments, full-stack capability, improved search and tool use, 20% fewer agent loops than previous versions. Fewer loops mean lower cost. Lower cost means longer autonomy. And here's the bold internal metric. M2.5 allegedly generates the majority of newly committed internal code and handles a significant share of operational tasks autonomously. If true, that's not assistance. That's integration into the company's workflow backbone. MiniMax is effectively saying, the future isn't just smarter AI, it's affordable persistent AI. So what do we actually see here? 3 companies launching 3 different strategic bets at the same time. OpenAI gives real-time collaboration powered by specialized hardware. Google gives deep structured reasoning with verification. MiniMax gives economically sustainable autonomous agents, speed, cognition, economics. Now here's the deeper question. Which one changes software development more? Does faster iteration accelerate innovation enough to dominate? Does deeper reasoning unlock higher stakes problem solving? Or does cheap persistence quietly automate entire workflows? Maybe the real shift isn't model intelligence at all. Maybe it's architectural specialization. Different hardware tiers, different reasoning modes, different pricing structures. Instead of one giant model doing everything, we're seeing a layered AI ecosystem emerging. Low-latency agents for flow, high-compute reasoning for complexity, low-cost agents for continuous automation. And when those layers combine, software might stop being written, it might be orchestrated. Developers won't just code. They'll manage AI systems that code, verify, refactor, and deploy. This moment feels less like an upgrade cycle and more like infrastructure being rebuilt. So now I want your perspective. If you had to choose one force that reshapes software the most, instant feedback, elite reasoning, or cheap always-on agents, which one wins? Because whatever wins, the way we build software 5 years from now is not going to look like today. Subscribe if you want sharp breakdowns of the world's most advanced AI and engineering systems. I'll see you in the next one.